And let's do this thing. Pop out the chat. All right, guys, can we all hear me? Those of you that are here? Maybe. Let me know if we can hear me for those of you that are in here right now. Awesome. Thank you very much. Also nice to see a friendly face. All right, so I think we'll put this over here. Give me a moment to just get everything set up. It has been a hot minute since I've done this little thing before. And we'll just roll with how it goes. We still got a few minutes, so we'll just chill here on the stream. Oh, that works. And we'll throw you into there. Just cut my video for the time being until we're pretty much ready.
Hey, Chris. Sure.
There we go. All right, that's better. Hey, Chris, absolutely. We're actually going to use your seek-to-seek example today, because honestly, that's a really, really good one. And I debated about using the one that we talked about on the forums first, but your example was a lot more complete than my sort of scrapped together one. So I'm really excited to show that one off because it it's really cool with just what you can do with the callback system and modifying the data as just going anywhere. So that should be hopefully an interesting take. Looks like a few more people are popping in. Still gonna wait until 7 to officially start. But we'll just give people a few more minutes to pop in if they want to. Well, it is 7 o'clock, and since apparently a few of us, it's currently 2 a.m. where we're watching the stream. Um, ah, nice call, Frank. Thank you. I will go and do that very quickly. Thank you for that reminder, because I definitely forgot to do that. So maybe we'll give them a few more seconds, but I don't want to keep you guys too long, since clearly we have a few folks who are joining us from, well, different parts of the world where it's currently 2 a.m. and I'm questioning your sanity right now, but I do appreciate you being here, Charles. So, all right. We'll give him a few more moments. Hello, Amber. Nice to see you. But otherwise, I think we will just go ahead and get a little started, go through a little introduction, and then we'll jump into the code. So, for those unfamiliar with the concept of a callback, callbacks can be thought of as code that runs on a certain trigger point. So in like web service, we could call a callback something that runs, say, when you click a button on the screen, and then it might throw a pop-up. In fastai, it's more along the lines of whenever we hit certain points in the training loop, what do we want to do? So, and also just so you're aware, after the stream is done, I'm going to post both of these notebooks likely onto walkwithfastai.com and just have a link to the video stream there as well. Might merge two notebooks together. We'll see how it goes. But this is very much so going to be we're going to code live together. So it's going to be very different from the course and very different from what I've done before. So we're going to roll with it. I know some feedback I got was you guys wanted to see sort of how I approach coding and debugging when it comes to the library. And so I'm going to try and do that here tonight. So the goals for today are we're going to look at 2 to 3 callbacks in detail. The short epoch callback, the save model callback, as those two are very beginner. We can kind of understand what they're doing through the source code. And then the teacher student, or more or less advanced model inputs that I recently helped debug with Chris Paw, who is in the chat with us, as it's an excellent example of, just what you can do with callbacks when, say, the data loader isn't enough. So first, we're going to look at FastAI's training loop. Now, obviously here you can see in my Google Colab instance, I have Walk with FastAI, FastAI, and Notebook Dev installed. I have Walk with FastAI here because we're going to use a little debugging tool that I made. It's an improvement on FastAI's training loop, and so we'll sort of walk through what that looks like. So I'm just going to import FastAI, and I don't have a GPU enabled here, I don't believe. Now, the first thing that we're going to do is I just want to show you guys a general overview of what FastAI's training loop looks like. So what we're going to do is call what... Sorry if there's background noise. My cat seems to be wanting out, so give me just a moment. Sorry. All right, we're back after the mild cat interruption. So as I was saying, FastAI has what's called synthetic, and it might actually not be imported here. It's not. So it's from fastai.testutils. FastAI has what's called a synth learner and a synth data bunch. And it's exactly what it sounds like. They're synthetic data bunches and synthetic learners. Now, you don't need a synthetic data bunch to, yes, the cat definitely triggered a callback of me opening the door. So what synth learner allows is it's literally a synthetic learner that doesn't need any sort of data loaders, model, or anything to really be used. So all we have to do is say learn equals synth learner. Now, what I want to show here is learn.show training loop. Now, I haven't imported the new version from Walk with FastAI yet. This is just FastAI's. And what this will print out for us is essentially what FastAI's training loop is and where everything is done. So we have the start of the fit, where we'll call a before fit, anything that happens right before we're essentially running our fit loop, at every epoch, when we're training, and all these different event triggers. I'll go into a little more detail when I bring in the Walk with FastAI version, but basically what the native FastAI one will do is we can see, all right, so I didn't add any callbacks into my synth learner, but FastAI will automatically use 3 different callbacks by default: train eval, recorder, and progress callback. And this is always used. And they're the minimal callbacks needed for really working with the FastAI training loop. Now I'm going to do from walk with FastAI .basics.training loop import star. And the reason why is I made a patch to show training loop today. So if I do doc learner.show training loop and pull up its documentation. So as we can see, show training loop will show each step in the training loop. I've added a verbose along with the ability to pass additional callbacks. This is more an educational sort of addition. That's why there's not an open PR for it or anything. Because really, once you get familiar with the training loop and how everything works, you don't really need to use verbose equals true at all. Just because you'll kind of understand how everything goes. But for the sake of this, we're going to do show training loop and verbose equals true. And now we have a much more detailed, give me a moment. Issues we did not have when I started doing the course, having a cat. But anyways, so back to what I was saying. So if we pass verbose, we get a bit more detailed look at FastAI's training loop. And here we'll go into more detail as to like just what exactly FastAI's training loop is, because if anyone's tried exploring learner.fit and its source code, it's like 5 lines of code that you can't really follow unless you dig really deep into what's going on. And I'm not a big fan of that. I'm not going to tell you to do that. It's a good way to understand what's going on internally, but we're going to look at this from a practical perspective. So we have the training loop, and generally it consists of big events being about 4 or 5 different ones. You have before and after fit, before and after epoch, and before and after train and validation, essentially. So I'm going to pull up the callbacks documentation here as well. And you can sort of see it's got all of them outlined here as well. But each more or less do exactly what they sound like. So before epoch is right before an epoch begins. Before train is in an epoch, right before you start the training portion, do something. And then you have the batch loop. Now, the batch loop does exactly what it sounds like. It's whenever you have your batches of data that you're, predicting on, you run, the loss function on, you update the weight, so on and so forth. And so you have before batch triggers, after prediction. So after prediction is obviously after you get a prediction. After loss is for after the loss is calculated. You can adjust anything that you want before the backward pass, before steps in the optimizer, after your batch is finished. So when people say the fastai training loop isn't very flexible, I believe it's more so they don't understand how the callback system works. Because you can do almost anything under the sun if you understand how this callback system works, where the event triggers are, and what's available to you at any given point. And so, we have the same triggers, more or less. We have the end of the training loop, and then the same thing over again for the validation. And then you have the end of the epoch, and then you have the end of the fit. Now, for a basic example, we're going to go through and sort of eyeball what fastai will do by default, which we kind of know what happens in the background, but we can see where it starts. So, for instance, train eval or train evaluation callback, when you start your fit cycle, it'll reset all your iterations, set epoch counters to 0, and make sure that your model is on the right device. Now, this is key, as this is why you never notice us having to do something like learn.model.CUDA before we pass things in, because fastai will do that automatically. Now, if you followed my torch vision adaptation or my torch adaptation, where we literally took as much PyTorch code and threw it into fastai, you might remember that we had to add something called a CUDA callback. Or I think it was a CUDA callback or a CUDA transform. And the reason why is how this is actually done is it looks at learn.train.device. And then what it'll do is set the model to that device. So if you want to run on CPU, you set your data loader's device to CPU in CUDA. And so, if we go through here and we follow the train eval, when we get before train, as the name would imply, we would expect it to set our model to training. And then in the batch, after the batch is done, update how far in the batches we're at. And then after the training, we don't really expect much to happen here. Instead, in start valid, it's going to set the model to the validation mode. So train eval does exactly as the name would imply. It only works with the model itself and setting, when the model needs to be going to train, evaluation, and the actual device. And then recorder is how fastai has all their fancy little fit outputs. The recorder goes through and keeps track of all your metrics. And then the progress callback is how we get our fancy progress bar. So that uses the fast progress sublibrary and just updates it as we're going through the overall fit regiment. And let me actually make sure I can look at what you... looks like I'm missing some things. Chris, you're asking, is there a way to see the available parameters we can manipulate during each one of these steps? Yes, there is. So this is why I had the callback documentation open. And so, yeah, available parameters. Yeah, so if we go down to attributes available to the callbacks, this is everything that we can have between just the basics that we had, that train eval callback that's sent by default, and the recorder callback. Now, it's important here to remember when each part is being triggered, so you know just what's available when. Ideally, yes. Honestly, I might do it at some point. Just make a table of when things are available. But we're gonna look at this in detail too. So things that are available at all times are, sorry. Well, actually, looks like it's cutting out my cats meowing in the background, so that's very nice. So things that are available at all times are more or less these six. What did I say about setting the device CPU, and what will be the appropriate callbacks for training aside from the defaults? I mean, appropriate for training is anything that you want in the training loop. We're going to go through a few examples, but anything you want to happen during the training loop, you just write it in a callback. That could be data augmentation like mix up or cut mix, or it could be, saving the best model with save model callback. And then setting device CPU, fastai magically handles that through the train eval callback. The meows are audible. Well, all right, as long as we love cats. The train eval callback is what sets the model to the appropriate device, and it's done right here in before fit. So back to attributes available and answering that question. So these first six are what's available at all times. That's the model, your data loaders, the loss function, optimizer, creating a new optimizer, and the current callbacks. Otherwise, as we go further in here, they have certain trigger points, and we can correlate that back to the events. So I'm going to go ahead and just have these on either side of the screen, and we can sort of walk through what I mean by that. So first we have data loader, current data loader used for iteration. So I wouldn't expect data loader to really show up until we're starting our training or starting our validation, because those events need access to data, and that's when they're assigned a data loader. X and XB, those would be our after batch, which for some reason, there it is. That's our after batch, I believe. Might be before batch. I'm going to cheat real quick and look at what I wrote, not here. One moment. It is before batch. Okay. Even I get confused by these things. Honestly, no one's memorized this entire library. I haven't memorized this entire library. Cheat when you have to, cheat when you want to. No one's really going to yell at you about it. Unless you yell at me, in which case, have fair game. But so before batch is when we first get access to a batch. So before batch is triggered right after we get a batch of data from our data loaders. And this data is stored in self.xb and self.yb. X batch, Y batch. And then if we want the individual items, X or Y. We're going to look more into working with those when we get to the seek-to-seek example. Predictions, we would only expect self.pred to show up after we've predicted. So in this after pred. Loss, after loss, end epoch, that kind of is always there. End iteration, what batch number you're at. The current epoch, this is from 0 to n versus this one that's 1 to n. And then again, current iteration. And then if you need anything more, there's also these additional properties added by train eval and recorder. Training is more or less the only flag that's really usable that I keep an eye on. But besides that, I haven't really touched any of these. So that is more or less how FastAI's training loop works from a functionality perspective. We're not going to go over it from a source code perspective because that's as much as some people would like to do that. Mastering the callback system is honestly a better value for you, in my personal opinion. So, for the time being, are there any other questions in regards to FastAI's overall training loop? I'll wait a little bit for any responses. I'll give it a few more minutes, but I also don't want to just sit here and be doing a whole lot of nothing. So in the meantime, and I'll just answer them as they come, this loop is generic enough for any type of model we want to train? Yes, it is. You can literally replace any PyTorch training loop with FastAI's training loop. It works with object detection models. It works with teacher-student. Attention-based transformers, RNNs, absolutely. I mean, FastAI had an RNN. There's an AWD RNN. So anything can be used. We're actually going to look at an attention model a little bit, but it's a seek-to-seek example. But yeah, anything, you can throw anything you want at this training loop. Any sort of model, and that's why I wrote the article about using raw PyTorch, because all it is just a wrapper. You can have everything else in PyTorch, have a complex PyTorch model, and as long as you understand like what your model needs, then you can write callbacks for it, and there you go, you're golden. And the seek-to-seek example I keep talking about is going to show just what that advanced option can be. But in the meantime, let's start looking at some scary source code and understand sort of a few implementations. So the first one we're going to look at is the show or the short epoch callback. And I was going to go ahead and copy this over here. And one thing you'll notice is all the callbacks aren't a whole lot of code. And the reason for that is they don't have to necessarily do much because the fit loop will do everything else for them. So short epoch callback, if we look, fit just a % of an epoch and then stop. So, we have our init, which makes sure if we want to have a short validation and our percentage and store those away. And then our actual trigger point is after batch. And the reason for that is we want to know, after how many batches, stop. And so what this code reads is if the current iteration divided by our total number of iterations available in the data loader is less than our % that we want, then go ahead and stop. So we've hit the, return. Keep going. Don't stop. Flip my logic. So long as we're less than the %, keep training. Now, otherwise, if we're currently training, raise what's called a cancel train exception. So if you want to stop any particular section of FastAI's training loop, any of these event triggers like after epoch, after validate, all of them have a cancel. So you probably saw that showed up here, like after cancel epoch, after cancel train. And so we have all of these. So if I do cancel, we have all of these exceptions that we can raise at any point during the training loop. And as a result, it will stop that particular section. So here we raised a cancel train exception. So if I'm currently training, it just completely stops that training cycle and immediately goes to the validation. And then here, if we have, short valid and we've gone through our % in the validation set, stop the validation. So I'm gonna write a very quick, and was I smart? I was not smart. All right, so we're gonna do a few things. I'm going to very quickly reinstall fastai here. And I'm going to provide us a little example of the short epoch callback. So if we do from fastai.vision.all import star, we have our callback source code there. Now, when it comes to minimal examples in my many bookmarks, I have this particular notebook bookmarked because if I need something fast, it has very quick examples of, single classification, segmentation, text classification, tabular, every single one of the main approaches that fastai has for you to test natively. It's there very quickly for you to run. So I'm going to go ahead and grab the pets data set, and we will quickly create a learner. We'll do DLS ResNet 18. And wait for that to finish downloading and doing all of its fun jazz. And just want to quickly show like it working, and it actually isn't going crazy. We do, so when we want to, actually this is very important. So there's a very distinct and important difference between passing callbacks directly to the learner and during your call to say learn.fit1 cycle. Because technically, so I created my learner and I could do callbacks equals short epoch callback. And that is perfectly valid. And then I could also do, equals short epoch callback. Absolutely, you can, there is a dynamic plot updater actually as a callback. We're going to quickly go through how I search the fastai source code for these things. That lives in callback progress. Is that a progress? Yeah, it should be progress, right? Yeah, progress. fastai has a show graph callback that will go ahead and plot your training and validation loss. And it has 3 little event triggers. So there's that for you, Charles. And for a little hint of how in the world I got there, because I know that was very fast. Generally, what my approach is so first I'll think, okay, what am I trying to do? I'm wanting to go to the callbacks. And then I want to think of something that relates to either I'm training or I'm showing something. And so we have, training, maybe tracker, maybe schedule or progress. And what I'll basically do is just look up here at the openings and, see if there's something that makes sense to what I'm wanting to look for. And then I'll just go from there. Now, in regards to the difference between this and this, when you tie your callback directly to your learner, like this is doing here, this will always be called anytime you do something related to the fit loop. And so what that means is if I were to say run this, and I did learn.validate, because we have self.shortValid, I'd only validate on 1% of my data, which after training, that's probably not something you want to do. So instead, anything that should be more or less temporary and you don't need it to be there, either when you're done training and you want to just see how you did through, classification interpretation or something, or you want to export and do inference, you should either remove the callback, which they can be found in learn.callbacks, or, and actually, There it is. Or you pass it to the fit cycle instead. And what that allows is only when you call fit is your callback there. And so it's only temporary, gets in, gets out. Do you want me to explain a little further, like on a few different details of when it might be more or less better? I explained it a little bit in the beginning, but in the simplest way possible. A callback is something you want done at some point during FastAI's training loop in certain sections. So in the FastAI documentation, there is specific descriptions of what is done where. So we have, before step, what's being done there. After prediction, what's being done there. And so anytime you want a particular event or behavior to occur, you should find the trigger point or where it should be done and then go from there. So, no, it's not injecting code into the learner. It's injecting code into the fit function specifically. Because the learner on its own is just sort of a handler object that does a few fancy things. Everything is really tied together through FastAI's fit. Because even when you call, learn.validate or learn.predict, well, not really predict, but validate, you're still running through the fit cycle. And actually, yes, when you're even running predictions, you're running through the fit cycle. So everything goes through learn.fit. So here, for example, we'll run through a very quick example and do learn.fit. For just one, we can see it's already done. Now, there's likely a little bug with that as to why it's not particularly going there and showing, but we're going to pretend to ignore that for right now. What callbacks do I use most during training? Gradient accumulation, mix up when I'm trying to do data augmentation. The standard ones that you'll see the most often in FastAI examples are generally what I use because they're used most often in FastAI examples for a reason. So while we wait for a few more questions to pop up, I'm going to go ahead and grab our second callback we want to look at, which is the save model callback. As it does a few more things that I think is a little more interesting. Yep, gradient accumulation as well. So, which maybe I said gradient accumulation. So we have the gradient accumulation callback here. And notebook dev isn't installed. That is buggy. A little fun fact about the FastAI library, if you're using it, I highly recommend you always install notebook dev along with it, because rather than doc showing you this, it instead shows you this. And I believe this also works with anything else as well. So we can have doc torch.cuda.is available. And it shows a pretty doc for Torch CUDA, even though it's not from the FastAI library. So we're going to move on to save model callback. Now, save model essentially does what you think I want to. When I'm training, I want to save my model at its best monitoring value. So I can choose to monitor, a metric or a particular loss. Now we're going to go through and look at how this is sort of implemented and what it's doing at the various trigger points, just to give you another idea of, this is sort of what you can do and how it's being done. So the first thing you'll notice is we have this little flag here, only train loop. And these are little private flags that allow us to basically not run on the validation. If we want to find out where those are, I believe callback.core import. This is the fun of doing live coding. I will try and get back on the origins of only train loop. However, I believe it should be either somewhere in here or... This is honestly how I do most of my stuff when I'm looking for something in particular with fastai. I just go through, I think it's in learner, and I just control F. Oh well, I will attempt to find that, and if I do, I'll post it in the live stream thread that I have on the forums, which I can go ahead and link to you guys here, because I'm sure a lot of you are aware of it, but some of you might not be. Give me just a moment. Here's where I will be posting links to the notebooks along with the videos, and I'll obviously look into the only train loop. However, for the time being, we can go by the name. It only activates on the training loop. So we have a monitoring value that we want, and then a file name to save the model, and whether or not we want it to run every epoch, whether or not we want to save, the optimizer, things that you generally need to think about whenever you're saving your model. And then the rest of the stuff is just bits and bobs for the tracker callback. So the real important trigger point here is after epoch. So after every epoch is done, ideally we want to look at what our old best was, what our new best was, and if it was better, keep going, otherwise stop. So reset on fit means so like my understanding at least of what this would do, but actually let's not even do that. Let's straight up look at tracker callback. So if I pull this here, reset on fit, it basically sits. So what reset on fit does is, and I'm looking particularly here, I focused on where reset on fit was being called and set, and then what was happening with it. So if we want to reset on our fit, or we want only the best value, or the current best value is none, we set it to infinity if we're looking for, the lowest value, otherwise negative infinity if we're looking for the highest value. So what this really means, this reset on fit, is if I made this learner with learn equals CNN learner, right? And I did data loaders model callbacks equals save model callback. What would happen is if it wasn't set to true, right? It was set to false, then I could run learn.fit, yada, 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 and then learn.fit again. And it would remember what I did in my last fit call and use those sort of metrics that we had and those best models and bring them over to the second fit call. So that's another major difference actually to when you would want something done in your learner directly versus in fit. Because if I just did learn.fit, say, and said callbacks equals save model callback. If I did learn fit again and I wanted that, I can't do reset on fit. And if I set that to false and I wanted access to what happened in my last fit, I don't get that. And so this is a clever way for us to keep track throughout fitting our model, how our metric was doing. So now if we go back into the actual event, right? So after every epoch, if I want to save on every epoch, I go ahead and save, which calls save. And then otherwise, on every single improvement, go ahead and run the rest of my after epoch. That's what this does. It does every other callback that does after epoch except for our callback. And then afterwards, we get access to, all the various little bits and bobs that come with after epoch. And since we had tracker keeps track of self.best and self.newBest. So if we have a new best, print that we found one, and go ahead and save. The code itself might look a little scary, especially like this super after epoch. After we go through save model, I'll introduce one other idea to you guys about this and the fact that callbacks actually have orders to them. But then, after we're all done, once we've finished fitting, we want to go ahead and just load the model. And that's all save model callback is doing. So after every epoch, I go in, I look at my metrics, I check and see if there's an improvement. If there is, I save the model away. And this is just what it looks like in code. Now, this is useful to look at just so you know what you have access to with tracker callback. But in reality, obviously, this is all you need. So questions in relation to tracker callbacks and save model callbacks specifically, and sort of how callbacks are structured in that sense. If there's any confusion, please let me know. We'll look at that sort of order thing I mentioned next. So if there's questions about like, how do you run multiple callbacks that have, multiple after epochs, we can look at that. All right, well, if there's not particularly any questions, I'll go through and catch up on them later if there are. Then let's go into this sort of order thing I talked about. So just like how any data augmentation has a particular order, and based on that order dictates when they're going to be called. And if you didn't know that, that's how FastAI's data pipeline works. So that's why I can have, into float tensor and my normalize in my after batch or batch transforms. And it will know to run into float tensor before normalize, because if we look at int to float tensors order and normalizes order, into float tensor has an order of 10, so it gets called sooner. Normalize has 99, so it's called at the very end. Callbacks are the same way. So I can look at save model callback, for instance, and look at its order. It has an order of 60. Now, I'm yet to fully figure out FastAI's ordering schema when it comes to things, but just so we're all aware of it, let's look at train eval callbacks order. We'll also look at recorder's order, and then we will finally look at I am blanking. Why am I blanking? Progress callbacks order. So you can see that trained eval callback has a negative, so it's always called first. Recorder has 50, progress callback is 60. What FastAI will actually do is when you start your fit, it will go ahead and sort all your callbacks by the order, not necessarily trigger each one by an order count. So that's why you can just throw it in, at any order. No, or everything related to the callback system is specifically FastAI. Like if we look at callback, it is from FastAI. So all of this that we've been doing is actual raw FastAI, not PyTorch. And so given these, various event triggers, if say I want, let's say for instance, I was using cut mix and maybe mix up for whatever reason. I'm not sure the logic behind it technically works, but we'll go with that for example, because they're data augmentations. If I wanted cut mix to happen before mix up, I would make sure that cut mix's order is greater than mix up's order. Now, obviously it's not here because they're both, designed to be not used at the same time. Yes, the order, Chris just asked, so the order we pass these callbacks in does not matter. No, it doesn't. Now, what we'll notice is if I pull up the progress callback source code, all right? Actually, no, it's not progress. Hold on. Which one was it? Was it recorder? A few of these callbacks are pretty clever when it comes to how they define their order value. Let's look at save model. Just had a regular, right? I'm going to go through the source code because there's a few of them that get extremely clever with how they define their order, and I want to particularly look at that. In the meantime, as I'm going through this, the same model callback, if I have 4 cycles for training, then each cycle it will load the best model at the end of the cycle. And okay. This save model callback, if I have 4 cycles for training, then for each cycle, it will load the best model at the end of the cycle from the set of batches executed on the cycle. If I'm understanding you correctly, then you are asking if I have learn.fit1 cycle for 4 epochs, and I have my callback as save model callback, then what will happen is it will run through all 4 of those epochs. And then if one improved over the other, then it will sort it as a new best. And then after fitting is all done, it will load back in the best model out of those 4 epochs or those 4 cycles. Let me. Well, this is a little perturbing, but in any case, if there's particular callbacks that you want to have run directly after each other, what I can technically do is say save model callback, for instance. That's not what I wanted to do. Dot order equals normalize dot order plus 1. Not quite the same. Equals, we'll do recorder. This way you guarantee that you know it's always done after the other and you don't have to remember, oh, which order did a particular callback have. And this is, you define it. So if I have back here where we have save model callback, I could technically do order equals maybe tracker callback dot order plus 1 if I wanted to. Before we move on to the seek to seek example, let me know what other questions we have first, because that's honestly as a whole all that FastAI's callback system is and training loop. If you want to adjust anything by the batch, we're going to look at that in the next example. If you want to adjust any metrics, any loss functions, let's say I had a pretty advanced loss function and I wanted to adjust the value for some arbitrary reason, then I can just write class adjust value callback. And my trigger point would be after the loss is calculated. So I do after loss, and the loss lives in self.loss. I could do, self.loss equals plus 100 if I wanted to adjust that, or whatever you want to do. So, when you're going through and you're writing all these different callbacks, it's, look at what you want to, adjust, what you're wanting to look for, prediction, loss, so on and so forth. Find the closest trigger point and then start writing from there. So unless any other questions pop up, I'm going to go ahead and start the seek to seek example. This is, so for a little bit of context, Chris, who is with us in the chat, posted on the forums asking about a debug point during. That is a really good question, Chris. Yes, there is. So if I want to inspect the input and outputs, FastAI has, or actually not even FastAI. So for instance, if I wanted to write a very simple debugger callback, and I wanted to adjust the inputs and outputs, I could do after pred, and I'm trying to remember. Yeah, it's a module. Don't mind me. I have forgotten. Isn't it something like pdb.trace? Yeah, like pdb. Yeah, I want to say it's pdb.trace. So if I wanted to look at, in your example, inputs and outputs and inspect them, I could just put a trace in after pred. And so now if I go ahead and do, learn equals CNN learner, and I say, resnet 30 or 18, I do learn.fit, thank you, set trace. And honestly, we can even just do that here. Thank you very much, Molly. So if I want to write a little debugging callback, I can call fit one and then callbacks equals debugger callback. There we go. So now I can do self.pred. There's my predictions. Self.law. I think it's self.x. Yeah, there's my x values. So I can get access to, what exactly is going on. And all I got to do is just write a PDB tracer. Ah, thank you. I figured fastcore had something. So fastcore has a very easy set. Let me go ahead and quit out of this. Fastcore has a shortcut for that. That's literally set trace. So thank you for that one. All right. So that's how you can do a little debugger. And, anytime you want to inspect anything during your training loop, there you go. I could set a debugger to do after pred. I could also set a debugger to do, after loss. And then just have another trace there. And you can just debug your entire training loop as you're going through it and skip over all the fastai stuff that it's going through until you get to your important parts. Yes, Frank, the power you have is unbelievable. So, all right. Craig asked, these are super cool. How important do you think novel callbacks can be in terms of model optimization compared to, say, traditional hyperparameter optimization that everyone does now? So that's a good question. Let me think about that for a moment. So I mean, they absolutely. Thank you. Okay, yeah, reduce LR and plateau. Yeah, no, absolutely. They have purpose, and they have use. So let's look at Frank's reduce LR on plateau. This is a very simple, thank you, novel callback that adjusts hyperparameters. So what this will do is reduce the learning rate once we've stopped improving. And, obviously we have the initials, and then after every epoch, compare the value monitored to its current best score and reduce the learning rate if there's no improvement. So it's a tracker callback. Yeah. Good point, Charles. And so, what we can look here is, I can actually just go through and adjust my optimizer's hyperparameters while I'm in my fit. And this is exactly how all of FastAI's learning rate schedulers work. So if I look at, what is it? Actually, let's go to the source code for that one, because that's in schedule. We're going to go ahead and go through and look at the schedulers for that. And I'll go ahead and throw a link to the documentation on that one. That should work, right? Yeah. There's a link to the documentation so you can follow along with me. But FastAI has what's called a param scheduler. And that's this particular callback here. And what this allows you to do is adjust any of those hyperparameters that you want at any point during the fit cycle. So, fit one cycle, the Leslie Smith, transfer learning, standard. I wouldn't say standard, but, for those that are familiar with, sort of what's state of the art and stuff, fit one cycle, it's only like 6 lines of code. And the reason for that is all I have to do is apply some sort of hyperparameter scheduling, which, as those docs will show, FastAI has a whole bunch available to you for adjusting the various, occurrences that happen during fit, the learning rate, the the optimizer gets propagated, what gets propagated. Anything you want to modify in FastAI's training loop, you can. And with relative ease if you know what you're particularly looking for. Does that answer your question a little bit, Craig? So it's yes, and it's designed to do that. And that's sort of what I mean by everything is done during fit. Absolutely everything is done during FastAI's call to fit. The only minimal source code you have to work your way around are that, progress callback and, train eval callback, and they don't really even do a whole lot. Yeah, absolutely. If we have an early stopping callback itself, we can look at, Charles asked, you could also set early stopping when validation and training are diverging too much. Absolutely. If you wanted to do that, granted, this one tracks whenever we have, we already had valid loss, but yeah, just adjust this line of code if you want to keep track of when they're diverging. That's all you got to do. It's not rocket science once you understand how the framework works. So unless there's any other questions, let's go and look at this seek-to-seek example that I've been anxiously waiting to do, because it's honestly, this is the part that honestly kind of made me want to write this or want to do this sort of presentation to begin with, presentation, walkthrough, what have you, just because it was so, for me, honestly, it was very like, oh, this is a very interesting problem. I want to know how to solve that with callbacks, because Jeremy's tagline is everything can be solved with callbacks, and the answer is they literally can. So I have a utilities file that I'm going to upload to the GitHub repo. And the basic idea is we have a very simplistic seek-to-seek problem. So like if I do, show batch, it's very much so, here's a question, give me an output. These are all very much so transformed because we did our own pre-processing for the most part. Now, in here, I have a custom model, right? I have all these various hyperparameters for an encoder and a decoder for seek-to-seek. And if I look at the documentation for it, this is just my own documentation, we can see that it has a particular forward function that expects a source, a target, and some sort of teacher forcing ratio. Now, out of the box, you're not going to be able to do this. And the reason why is fastai doesn't pass the target to the model. It only does the source, because that's sort of what you expect. You pass the inputs only. Now, for those of you very familiar with the data block API, your next probably idea would be, oh, okay, I'll just send the input and the target as my inputs. Well, you still need to get the target, because if it's in the inputs, then it's never going to see it. And so you have this sort of unique little situation where the data loaders aren't enough, and there has to be an easier way. And there is. Teacher forcing. So I called this teacher forcing callback, because it's kind of what we're doing. We have teacher forcing ratio. And I'm going to write, so we'll call this, a callback that sends targ to model and adjusts teacher forcing ratio. So on my init, right, I'm going to want to probably store that teacher forcing ratio. So we'll call it, teacher forcing ratio. Call it an int. We'll say 0.5. And we'll say, self.teacher forcing ratio equals equals teacher forcing ratio. So now I have that particular hyperparameter I want to tune in the model, right? Or I want to use along with the target. But how do I get the target? So this is going to be on that before batch, right? Because we want the data fresh out of the data loaders, but the model hasn't seen it yet. And our x's and our y's live in self.xb and self.yb, right? Well, they also live in self.x and self.y. The main difference being yb is a tuple and y is just the actual values. So to get this crazy model to work, because I can do, right now, learn equals learner, DLS, net, loss function equals cross entropy loss flat. And I can try fitting. And obviously we know it's going to break because it, doesn't have the target. So all we need to do is set, so we're going to grab our x and our y that come with our batch. And we're just going to override self.learn.xb and have it be x and y. Now, why am I doing learn.xb? I'll sort of show you why. And this is another little fastai magic where it simplifies things. Because if I wanted to adjust learner a lot, which callbacks do, I'd need to write, self.learn xb yada yada so many times. Actually, I think the better example is, let's see what happens if I don't do that. If I don't do that and we do fit callbacks equals teacher, in case it wasn't clear, this is all I have to do to get my model to work. And if I wanted to include the teacher forcing ratio, just do self.teacher forcing ratio. Whatever xb is what will be sent to the model, and you can assume it'll be like star xb. So now we have, my x, my y, my teacher forcing, and I can fit. Maybe. What did I do wrong here? Well, first part is you'll notice we get a user warning. You are shadowing an attribute that exists in learner. Use self.learn.xb to avoid this. All right. We'll do learn, because fastai actually understands what you want to do. Because I wanted to set the callbacks xb, but in reality, everything is tied to the fit function, right? And so if you want things to go back and forth between, let me figure out how to phrase this a little better. Callbacks in of themselves are independent of each other. So if I do, self.x and self.y, if I have another callback where I may be here, right? Like I said, self teacher forcing ratio here. I can't have another, callback where it's like class student forcing ratio callback and expect that, on my before batch. And yes, Molly, that might have been on purpose that I raised the error. So right now, what I can't do is, if I wanted to use that same teacher forcing ratio, I can't do self.teacher forcing ratio to get access to it, right? That doesn't make sense. And it wouldn't make sense because this callback isn't related to this callback. Callbacks can communicate with each other through the learn object. So anything that you want to have permanently stored in your callbacks, essentially, while you're going through the fit cycle, you need to set self.learn to have that value. So for instance, here, maybe do def before fit self.learn that teacher forcing ratio equals self.teacher forcing ratio. And then what that allows is this callback can now talk with this callback because they have sort of the same values and they can look at the same things. But to adjust my model or to adjust my inputs dynamically and have a particular complex model set up like we had here, where it expects 3 different inputs, but fastai by default will only send source. Really, if we didn't have teacher forcing ratio, it's all of 3 lines of code. And that's not 3 lines of code with magic happening in the background that you don't understand. It's 3 lines of code. In the beginning of my batch, grab my X, grab my Y, set a new X. It's very intuitive and still gives a lot of freedom to the user to adjust literally anything happening in FastAI's sort of training loop. And so hopefully what I would really like is that this sort of reduced the confusion about FastAI's training loop, because more or less I'm done. This is this is as far as I had planned. So from here we're kind of just rolling by Q&A and talk about certain things, but I wanted to do this as a video and stream rather than necessarily an article, because even if I did like 3 articles on this, I don't think I would get the information enough out there. And I don't think it would be as immersive, as interesting, and cover as much as I really wanted to versus this, how long have we been going at this? Maybe an hour? Yeah, an hour and 18 minutes. So what I hope is that, maybe you guys come to this video back later, or you learned exactly what you need in order to really understand FastAI's training loop, understand the magic it does, and why it does a particular magic. Besides that, what questions do you guys have for me? Rohit, I'm a beginner to FastAI. Can someone share some resources that don't have a steep learning curve? It depends on what you're trying to go through and do. FastAI's course is good. The book is free, so if you want a book and prefer that, that's also good. If you want to mostly understand the concepts, and if that's still a little too much, I started out with course v3, and so that's the previous course version. And if you focus on understanding the concepts over the code, and understand the FastAI 2 code, honestly, that's the only course I've ever taken. At least I took for a long time. I've taken, more courses since then, but that initial course can take you very far. And after that, it's just, playing with the library. And there's a perfect example. Frank just commented, I just wrote that learning rate reporter using a callback in the last 10 minutes. So it's very quick, very easy, and you just roll with it. And honestly, I'll bring you guys onto the screen. That way, if folks are interested, they can sort of look at the chat. This is sort of where I was going with that. But otherwise, yes. Definitely, if you are not a part of the Discord or the forums, I highly invite you guys to come join us. We're a very friendly community, and I'm very proud to say that we are. And so even if you don't necessarily use FastAI and you just use, PyTorch, you can come learn with us. The Discord versus the forums, the Discord is more open discussion, and sort of, here's, we'll talk about various concepts. Usually it's fastai dev stuff or debugging, but a lot of times it's also like, hey, I did this thing. Can someone give me feedback? Whereas the forums is more like, if there's a particular topic that you want to talk about that you think, someone might look back on and come to later, or you might, even if you started on the Discord, throw it on the forums. Because I mean, I have numerous forum discussion posts, and I mean, literally, I think my first forum post ever was a very simple, what is FastAI's data block API, something like that. So, from there, I'm more or less gonna. Well, no, we'll sit here and talk for a little bit, have a little bit of interaction. All right, well, not to add too much awkwardness, I'm gonna go ahead and cut my audio and cut my video, and more or less chuck the rest of this out from the end of the stream. But I do appreciate you guys, being here for the hour and 23 minutes that we've sort of been talking about this. And I'm glad that a lot of you have had a very positive response to this. Because this was a little nerve-wracking for me. I've never done live coding like this sort of situation is. So, I'm glad this went well. I do plan on doing this again. The next one that I want to look at is FastAI's loss functions. Specifically, what I mean is, if you notice in this example, we used cross entropy loss flat. And if you've used loss functions lately, the newest torch tends to throw you an error about something's not implemented. We're going to try and look at that next week, if not the week after, if I just don't happen to have time. But that is something on my to-do list. And yeah, thank you. Thank you guys for coming and watching. Really appreciate it. It's fun. I've missed doing this.